Thank you, Zhao, for the introduction. And I want to say I'm really, really very grateful for the invitation to share this research I've been doing on artificial intelligence and the political philosophy of the future with you all. It's really a wonderful community of researchers that you have here, and I am especially appreciative of the hosting of Alexandre, who I think is not only very smart, but also has a kind of wisdom about how to build community. So I look very much forward to joining in to your community and sharing and dialogue with you all about these issues that are so pressing. The research I'm going to share is based on a forthcoming book, which I'll share with you all along with some PDFs of the slides and text of this talk and a resource list later. As a teenager, learning to do construction work on buildings, I got some advice from an old timer who was watching me run around, grunting, scurrying, lugging cinder blocks, shoveling sand. He said to me, work smarter, not harder. Work smarter, not harder. It was good advice. Nowadays, I see many of us scurrying around in other ways, losing track of the larger frames of our lives, suffering burnout, addiction, divorce, health collapse as individuals, and other analogous crises as communities and countries. What kind of thinking might be most helpful as our world becomes increasingly dominated by smart cars, smart farms, factories, schools, cities, smart battlefields? In this new context, we may need to follow another kind of advice. Live wiser, not just smarter. The overall aim of this talk today is to explore what this might mean. How can we promote not just a smarter planet, but a wiser Earth? In this talk, I'm going to try to first frame some key problems for AI and our future, distinguish two kinds of reasoning, one I'll call monological inference, and the other dialogical negotiation, to help us address those problems. Then I'm going to describe two models of AI, the Turing machine and what I'll call the Turing child. And then finally, I'll explain 7 strategies for developing Turing child systems and programming for collaborative wisdom that uses dialogical reasoning to promote a wiser Earth. Sometimes slowing down and taking a deep breath, especially before trying to deal with issues like these, helps the work go better. And I know a lot of you have been flying in from elsewhere and so on. I hope you won't mind if I calm myself down a bit by sharing a song with you to help set the mood. Okay? This is a song I wrote. Oh, 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 I'm gonna slow right down, yes, so I can get there sooner, yes. I'm gonna slow right down, so I can get there today, yes. I'm gonna slow right down, oh, maybe even come to a full stop. Oh, maybe if I come to a full stop, I'm gonna get there right away. Yes. Thanks. Well, I feel like I'm already here a little bit more. It's Good, good. So framing the problems, part one. Gandhi once commented that civilization is not an incurable disease, but we should always remember that the English people are currently afflicted by it. What might this mean today? Today, our global civilization is structured by ways of reasoning in economics, governance, technology, and morality that threaten our species with ecological collapse, with pervasive injustice and the threat of mutually assured destruction, with the domination by superhuman machine intelligence or superhuman machine foolishness, and with the kinds of moral relativism and the annihilation of meaning for human life, for framing our lives. Imagine that an alien anthropologist from some star, from Alpha Centauri, arriving on Earth, and she's observing all this, and her first note home to her graduate advisor says, "A species which imposes such radical existential threats upon itself. What are they thinking?" You can imagine that her alien graduate advisor back home might reply something like this. "Clearly, their dominant reasoning strategies are, in a profound sense, irrational. The central research question is, how are they thinking?" I want to suggest that our dominant idea about how to think best is to try to think ever smarter. This is part of a project since the 18th century Enlightenment and the Industrial Revolution to develop what IBM has called a smarter planet, a planet where everything and everyone is instrumented, interconnected, and in some sense, intelligent. Theorists like Ray Kurzweil and Max Tegmark have laid out visions of how all this may culminate in some form of artificial superintelligence. But in considering this dream of artificial superintelligence, perhaps we need to reflect more. What exactly is it? Intelligence. Let me offer a proposal for our purposes today. Okay. I'm going to propose to understand intelligence as the ability to sustain and or enhance one or more values in various contexts over time. Know some key features of this conception of intelligence. First, it's guided by values. We can only distinguish more versus less intelligent behaviors if we care about the consequences. In a world without any values, there are no wrong answers, and there are no smarter methods or machines. Second, intelligence reshapes or adapts the self and or the world to reflect those values, to sustain them and enhance them. Third, it can take many forms. Calculating a mathematics solution, negotiating an agreement, writing a melody, constructing a piece of furniture, sharing an intimate feeling, cooking a new dish, keeping warm, nurturing an offspring. In this sense, organisms and biological communities may exhibit intelligence, and so may machines and other systems. Intelligence, in this sense, does not require consciousness. Further, intelligence may be partial and limited, falling short of wisdom that responds appropriately to the full range of values that we should hold in our lived context. It may just focus on one or a few. Contrast intelligence with wisdom as a concept, which we might define tentatively in this way: as systematic intelligence that responds appropriately to the full range of values that we should hold in the context in which we live. In that sense, wisdom is human ecological. It deals with all of our relationships with social, natural, and the like. Unfortunately, many people and groups who aim at high levels of intelligence often focus on only one or a few relevant values, very unwisely. Artificial intelligence, what is it? Well, it's created by artifice, by a design process that, at least initially, in part, is guided by explicit intentions. It's typically silicon-based nowadays, but it need not be. It is traditionally programmed by a person or a team, but it can be designed to use evolutionary processes, for example, to program itself. Today, I'm going to use this intentionally very broad definition of AI that really includes everything from the minimal intelligence of a heating thermostat, which sustains a certain value of temperature in a room, to the most advanced forms of machine learning like GPT-3 and Wu-Dao 2.0. It's useful to distinguish varieties of artificial intelligence as narrow AI or artificial general intelligence, which is hoped to achieve some level of intelligence comparable to the general intelligence of a human, or artificial superintelligence. Our civilization is pursuing two projects. One is the ever smarter planet, and a second is the artificial superintelligence to run it. A key danger of the Smarter Planet project is that it can turn our life systems over to managers that are smarter without being wiser. They may maximize one or a few values very efficiently, but leave out others of vital importance. Think, for example, of the many functions that farmlands serve in ecosystems. If a smart system manages them solely to maximize the production of tons of soybeans per hectare, think of how it will foolishly ignore the vital ecological services of hydrology, wildlife, carbon sinks, conservation of landrace seeds, and also vital social functions like providing jobs, homes, green spaces, and even community identity. A key danger in pursuing artificial superintelligence, the second project, is sometimes referred to as the friendly AI problem, which is often assumed to be simply getting AI's values to align with ours. We want to be friendly by being friendly to us. But there are really two distinct problems here. First, we don't want an artificial superintelligence to simply align its values with its creator or its owner, because bad people could use it for very bad purposes. Very bad purposes. So there's the challenge to create AI that promotes what is good and right. But then second, how well do our own values align with what is good and right? If they don't, then the artificial superintelligence that, if we manage to create one that works for the good, it's going to be critical of us. So the challenge becomes, how do we merit its friendship if it's the kind of AI that we hope to actually create? To address these challenges, I want to distinguish two kinds of reasoning that provide, in a sense, two kinds of intelligence. Monological inference is what I'll call one, and the second, dialogical negotiation. So first, the reasoning that takes the form of monological inference, which employs algorithms. The first systematic articulation of inference in a formal logic was provided by Aristotle's theory of categorical syllogism, with its set of algorithmic rules that are used to generate categorical conclusions from categorical premises. For instance, there's the rule that if all A are B and C is A, then C is B. And to apply this algorithm in a rational argument, you simply need to input a set of premises, like, for example, that all men, A, are mortal, B, and Socrates, C, is a man. Excuse me. And then you just run the algorithm, and you get the conclusion that Socrates is mortal. Okay. Now, sorry. There are many ways of algorithmic thinking that have been embedded in our civilization, and lots of forms of formal logic that have been developed. But Euclid's Elements of Geometry and then Newton's physics provided very sophisticated and powerful theories of space and of the laws of motion that were developed and were so impressive that for many people, they were taken to be the paradigms not only of scientific achievement, but of rationality itself. This inferential model of reason is monological in the sense that it starts from one point of view, like in a monologue, and one set of premises, and it draws conclusions. And it can all be carried out by a single individual or a single machine. Given the right data and axioms, a Newtonian can work wonders predicting, for instance, how to shoot a rocket to the moon. In the 18th century, Jeremy Bentham and Immanuel Kant adopted this same core conception of rationality as their model for thinking about ethics. They sought one or a few principles that would enable them, like Newton, to provide the kind of laws of moral motion, to create an ethical rocket science that they could use for a set of premises about data of the world and axioms of ultimate value, and then, following logical algorithms, infer conclusions about how to act. For utilitarians like Bentham, the fundamental axiom of ultimate value was the greatest happiness principle. Always choose the action that will yield the greatest net happiness to all concerned. For the duty-based ethics of Kant's categorical imperative, the fundamental axiom could be expressed as act only according to that policy that you can rationally at the same time, will as a universal law. Or also put it in alternative ways, including never act according to a policy in which you treat other rational creatures as means only, as mere things, but rather always treat them with respect as ends in themselves, so that you could, in a universal way, will your policy from their point of view. In mainstream Western moral theory, at least as it's practiced in English-speaking countries, where much of the current work on ethics and AI is done, the dominant focus is on alternative variations of the utilitarian and Kantian approaches, especially utilitarian. Sometimes the two yield essentially the same practical conclusions, but in many important cases, they don't. Researchers and students are faced with dilemmas. Which ethical approach to choose? In the United States, a dominant pedagogical method in universities is to teach by focusing on ethical situations like the trolley car dilemma. And they do this for two purposes. One is to force students to clarify their own intuitions or prejudices about which ethical principle they believe is more fundamental. And then second, to give students practice in the kind of moral reasoning that both Bentham and Kant assumed was appropriate in ethics, namely monological processes of inference that use algorithms to go from premises to conclusions. There is a really fascinating documentation of this pedagogical method in a YouTube video by really an exemplary teacher, Michael Sandel of Harvard University. Teaches one of the most popular courses at Harvard, Justice. And in it, he has students imagine a trolley car that's rolling unstoppably down a track towards 5 unaware people who it will run over and kill, unless it's diverted to an alternate track. And so he says to the students, you can see the car and the people and your position, so you have a switch that will shift the track and make the trolley go left and avoid those 5 people. But there is an innocent person who's standing on the other track and who will be killed as a result. The dilemma: should you pull the switch and kill the one to save the many? Yes, students offer their views, and he draws out of them arguments that illustrate the contrasting utilitarian and Kantian analyses. For instance, a utilitarian might argue that you should sacrifice the one for the many and pull the switch. A Kantian might argue, or at least hesitate, maybe even refuse to pull the switch, because this might treat the one who's being sacrificed as a mere thing, as a means to save the others, and because maybe she couldn't will it from the point of view of the person to be sacrificed. So there's dialogue with the students on all this. And the students struggle with this dilemma, but most of them in his class in the video gravitate towards the utilitarian choice. Most of them want to save the many by sacrificing the one. Then Sandel presents a variation on the dilemma. Imagine you are a doctor with 5 patients in your clinic, and they each need a different organ for a life-saving transplant. And you have a healthy patient who's asleep in the waiting room. Isn't this the same dilemma? You could anesthetize the healthy patient, harvest his organs, and save the others. What should you do as a rational utilitarian or as a Kantian? Sandel asks for a show of hands to see how many would sacrifice the one for the many in this case. And the students, they just groan, just like, ugh. They're horrified. In particular, they're horrified because they just became sort of rational utilitarians, they think, and now they're seeing that they may be obliged to sacrifice the innocent sleeper according to their principles. But then one student who's way up in the balcony, he raises his hand, and Sandel is excited as a teacher. He thinks, a diehard utilitarian, woo, you know. You can see it in his face. But then the student offers a really interesting comment. The student says is, well, I wouldn't sacrifice the healthy person, but I get one of the sick people dying anyway to sacrifice themselves for organs to save the other 4. Now, when they hear this suggestion, all the students in the room, they burst into applause. This is great. It's a way out of this horrible dilemma, you know? But then with practiced calm, Sandel lets the excitement die down. And then he turns to the class and he says, well, that's a good idea. In fact, that's a great idea, except for the fact that it completely ignores the whole point of the philosophical example. And then he abruptly drops the discussion and he turns to another case. Now, in doing this as a university professor of philosophy, he's following a common practice, at least in the US. He's reinforcing the idea that ethics is about learning to make hard choices in the face of dilemmas. And it's about the idea that the rational way to make such choices is you pick your moral principles and then you stick to them using monological processes of inference. But notice something. In real life, the student with a third option is just the kind of innovative thinker we would want on our team. We want folks like him in the dialogue, brainstorming other creative options. Options like maybe polling the terminally ill to see who might have a motive for making such a sacrifice. The search for new ways of framing options that are available and for exploring people's underlying interests can often provide win-win outcomes by, as theorists of this say, increasing the size of the pie. Or they can even provide outcomes that stop framing the situation as a conflict at all with winners and losers and see it instead as a shared problem that participants are collaborating on. Approaching ethics this way, we would want to make use of an alternative model of rationality. So that gets us to part 2. Reasoning as dialogical negotiation that follows strategies rather than algorithms. Instead of algorithmic rules to follow, dialogical reasoning is structured by strategies that guide. They invite and they suggest methods of observation and discernment and search and creative invention. Instead of an inference from premises to conclusion as in formal logic, the process of reasoning would be of this basic form. Step A, you encounter somebody else who has a different point of view. Step B, you pursue strategies of negotiation or problem solving in dialogue with them. And then step 3, you do it until you reach some kind of genuine voluntary agreement. The Harvard Negotiation Project put out a book called Getting to Yes some years ago that proposes some guiding strategies for doing this. 4 of them are kind of core. One is multiply your options. So if you face a dilemma, look for alternatives. A second basic principle is focus on the interests behind positions. Learn more about what the other person really wants so you can explore more alternative ways to satisfy their concerns. Third, separate the people, what we might call the people issues, from what we might call the sort of the engineering problems. So sometimes what's at issue in a conflict, it can't be healed with any amount of money or material goods. It needs an apology or a public acknowledgement. The relationship needs to be fixed rather than just things in the world being moved around. Yes? I'd like to go through the talk if I could, if it's okay, just because, yeah, okay, thanks. I'm looking forward to the questions very much though. Okay. In the last 50 years, research on negotiation and conflict transformation has yielded detailed accounts of these kinds of strategies and a host of others that help parties get to yes, to engage in group problem solving, community-based collaboration, mediation, dispute resolution, conflict transformation, and peacemaking. These are all terms that are used for different variations of all this. And studies of dialogical reasoning have spread to a wide variety of fields. So here's some examples. Getting to Yes is a classic manual on negotiation strategies that are used in North America and international settings. Jean-Paul Lederach's Preparing for Peace draws on traditions of ethnography and appropriate technology, as well as Paulo Freire's community-based approaches to collaborative learning to demonstrate methods for studying and improving practices of dealing with conflict in different cultures. Ramsbotham, Woodhouse, and Mial's book on contemporary conflict resolution provides an excellent survey of a host of these traditions in their different contexts around the world. And there are lots of others here. In different ways, these research traditions aim, like Gandhi, to change our civilization. We live in a culture in which peace is obscured. It's defined in terms of what it's not. It's not war, not conflict. And as a state rather than as an activity like its opposite, war. So in English, for example, we can say that nations are warring in the Middle East, but we can't say that nations are peacing in Scandinavia, even though very clearly they are. Because we lack a verb for peace. And that reflects something fundamental about our culture in the English-speaking world. It's all because, I want to suggest, or in major part, because our culture is dominated by practices that assume that conflict is essential to life. And the result is a culture of conflict in which the core metaphor for life is there's two islanders There's one coconut and they both want it. On this view, everything else, economics, politics, religion, it just adds more islanders and more kinds of coconuts to the basic situation of conflict. Now, many of the studies of dialogical reasoning that I mentioned actually start with a kind of conflict-centered view, and they simply look for ways to reduce the violence used, to get out of the cycle of an eye for an eye and a tooth for a tooth, or to move away from these vengeance cycles to more win-win kinds of solutions, right? But other practices of dialogical reasoning actually seek to enrich the range of metaphors with which life is viewed. For example, as a shared problem-solving process, where there aren't winners and losers. There's just solutions and collaboration. Or a dance. Or they may use the process of birth as a metaphor for life. Birth seen as a struggle in which lives may be at stake, but there's no conflict. The pregnant woman and the fetus, they're not trying to win against each other. Instead, they're both sharing a process in which they're going to be transformed as individuals into a mother and child and enter into a new set of community relationships. So think about life not as a conflict between islanders, but as a process of giving birth to new structures of community. Now, what are some distinctive features of these traditions of dialogical reasoning? First, they understand the reasoning process as involving two or more real people with substantively different language, beliefs, and norms for their starting points. And the challenge for these parties is to negotiate those differences and to develop new language, practices, and plans of action on which they can agree. Second, they commit these traditions to seeking genuine agreement through nonviolent practices of investigation and persuasion without threat or coercion. Third, they use variations on the four basic strategies that I mentioned earlier. Multiply your options, focus on interests behind the positions, separate the people issues from the engineering problems, and look for objective criteria. Look for criteria that are independent of my will or independent of your will, but that we can agree might be relevant criteria that we could use to start to work out a solution. Objective in that sense, independent of us individually. Note that these advices or basic strategies take the form of open-ended imperatives that guide. They are not algorithms. If you were teaching a class in computer programming and ask somebody to write some algorithms down for you and they wrote these down, you would say, wait a minute, we're not there yet. A fourth common feature of these traditions that I'm talking about is a shift away from the golden rule, which says, do unto others as you would have them do unto you. As typically interpreted, that rule can provide an ethnocentric approach that invites colonialism, invites imposing our own preferences and values on others, treating them the way we would like to be treated. Instead, these traditions of dialogical reasoning ask us to start by inquiring into other people's interests and values and to shift to what we could call the rainbow rule, which says, as a starting point, do unto others as they would have you do unto them. Do unto others as they would have you do unto them. A fifth feature of these traditions is that they understand the elements and the aspects of the reasoning process in emergentist rather than static or reductionist ways. For them, the meaning and the truth of sentences, the identities of the selves and the communities stating them, and the social realities involved all emerge and grow or otherwise develop during the dynamic course of negotiation. question often is not, what did I say, but what am I trying to say? What am I trying to do? Many of the distinctive features, practices of rationality in these traditions focus precisely on methods for getting shared meanings to emerge in forms that express increasingly truer views of our options and become more agreeable to all, become more objective in the sense that they're less partial, they're more inclusive in the way in which historians talk about objectivity, for example. In his experiments with truth, Gandhi developed a kind of experimental method for discerning, demonstrating, and defending emergent, objective moral truths through practices of what he called nonviolent clinging to truth, or satyagraha. If there's time later, we might explore how such methods can enable people to discern, demonstrate, and defend moral truths experimentally. Along with, we might also explore in more detail some of the systematic statistical studies of progress in using these kinds of methods and their rates of success over the last century and a half, which are quite remarkable. But to sum up so far, I want to suggest the following, that we need to move from a primary reliance on the 18th century model of rationality as monological inference that makes us smarter, to a more inclusive 21st century model of rationality that draws on monological reasoning to express individual voices, but then seeks to resolve their conflicts through more inclusive forms of dialogical rationality that make us wiser and that help us deal not just with the complicated problems like landing on the moon, but also with what are sometimes called complex or wicked problems, like ending poverty, problems that involve multiple, divergent, incongruous perspectives and frames of meaning for understanding values and elements and dynamics. If we have more time at some point, either in the Q&A today or later, I would be very interested in talking with you all about how these two paradigms of reasoning are transforming the ways in which people understand economics, politics, and morality. However, at this point, I'd like to focus in on their relevance to artificial intelligence and the ways its technologies are transforming our world. In particular, I want to focus on two models of artificial intelligence, two ways of thinking about what AI is. What I'll call the Turing machine versus the Turing child. So the work of Alan Turing played a key role in the development of computer science in general and AI in particular. And I want to focus here today on his classic paper on computing machinery and intelligence, where he introduced the familiar imitation game as a way of operationally defining computer intelligence. And the paper also developed a clear and explicit account of what's often referred to as the Turing machine, or that defines what's often also called the standard model of the modern programmed inferential algorithmic computer. What's generally overlooked, however, about this essay by Turing is that in a final section of the paper, he introduced a different, second, basic conception of AI, a conception of what we could call the Turing child. And he offered it as a vision of a machine that learns through dialogue and socialization. So introducing his conception of what became the standard model of the Turing machine, Turing says in the paper, the idea behind digital computers may be explained by saying that these machines are intended to carry out any operations which could be done by a human computer. The human computer is supposed to be following fixed rules. He has no authority to deviate from them in any detail. We may suppose that these rules are supplied in a book, which is altered whenever he is put on to a new job. He also has an unlimited supply of paper on which he does his calculations. So our word computer comes from these human beings who are working for big companies who are doing computing in this kind of way. Now, some key elements and functions of the machine that he described involve, it's got input, it's got storage, it's got algorithms, and it's got output. Okay? Turing was a really extraordinary thinker, though. And after developing this machine model at some length and describing how it might make progress over the coming 50, 60, 70 years, in the closing section of his paper, he introduces a really, I think, revolutionary second model of the computer as child rather than machine. The way he does it is this. He says, in the process of trying to imitate an adult human mind, we're bound to think a good deal about the process which has brought it to the state that it is in. We may notice three components: the initial state of the mind, say at birth, the education to which it has been subjected, and other experience, not to be described as education, to which it's been subjected. Instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulates the child's? If this were then subjected to an appropriate course of education, one would obtain the adult brain. It's important to stress that this second model is not a tool that's programmed by a user. It's a child that's educated in a community. Turing means this clearly, quite literally. He goes on to note, for example, it will not be possible to apply exactly the same teaching process to the machine as to a normal child. It will not, for instance, be provided with legs, so that it could not be asked to go out and fill the coal scuttle. Possibly it might not have eyes. However well these deficiencies might be overcome by clever engineering, one could not send the creature to school without the other children making excessive fun of it. It must be given some tuition. We need not be too concerned about the legs, eyes, etc. The example of Miss Helen Keller shows that education can take place provided the communication in both directions between teacher and pupil can take place by some means or other. Note then some key features of what I'm going to call a Turing child. The child machine will need to have a body and engage in dialogical reasoning and interaction. The programming structuring such behavior will require kinds of interaction that are not monological reasoning or algorithmic calculations taking place in a formal object language, or at least not limited to those. They will have to involve dialogue in which the teacher and the child machine repeatedly renegotiate the meanings of terms and sentences. What do you mean by that? They will also have to be able to move back and forth between the object language and the meta language standpoints. In that regard, with reference to Bertrand Russell's introduction of the theory of types to avoid paradoxes of self-reference and infinite regress in Principia Mathematica, Turing makes the following very revealing comment. He says, the processes of inference used by the machine need not be such as would satisfy the most exacting logicians. There might, for instance, be no hierarchy of types, but this need not mean that type fallacies will occur any more than that we're bound to fall over unfenced cliffs. Suitable imperatives expressed within the systems, but not forming part of the rules of the system, such as do not use a class unless it's a subclass of one which has been mentioned by the teacher, can have a similar effect to do not go too near the edge. I would like to suggest that we're reaching a critical moment in which the obstacles to creating Turing child machines that have these characteristics are receding. It's the stage that Max Tegmark describes as Life 3.0, with entities that can intentionally redesign their hardware and their own software. We are further at a stage in which cutting-edge textbooks in AI are reframing their core goals. For instance, Stuart Russell and Peter Norvig note in the newest 4th edition of their classic intro book on AI the following. Previously, we defined the goal of AI as creating systems that try to maximize expected utility, where the specific utility information, the objective, is supplied by the human designers of the system. Now, we no longer assume that the objective is fixed and known by the AI system. Instead, the system may be uncertain about the true objectives of the humans on whose behalf it operates. It must learn what to maximize and must function appropriately, even while uncertain about the objective. I want to suggest that passages like this are evidence of a growing, not complete, but growing awareness of the need to introduce dialogical approaches to reasoning in work on AI. Not just in the way in which computers are structured, but perhaps even more in the ways we understand the entire systems of society, technology, and nature of which they are a part. Perhaps later, it would be interesting to discuss different readings of the history of AI and where we're at right now. But for now, I want to just go ahead and sum up the key things I've been saying. And this chart lays them out by contrasting these two models of AI. Since I think the Turing machine model is pretty familiar to everybody, let me just repeat the key features of the Turing child model. Okay? So Turing children, in terms of their style of reasoning, it's multi-perspectival and collaborative and dialogical. And in terms of the process of reasoning, it uses guiding strategies to arrive at shared solutions or genuine voluntary agreements. In terms of the starting point of the reasoning process, it begins with different points of view with different meanings that are ascribed to terms and different beliefs and rules and values. In terms of the process of reasoning, it involves problem solving, conflict resolution, in which any meaning, belief, or value can be renegotiated. In terms of the goal, it's to reach genuine voluntary agreements. In terms of the conception of truth that's at work, it's one of the cultivation of shared understanding of emergent objective reality, of less and less partial, more and more complete, inclusive, well-integrated understanding. In terms of the nature and status of the reasoner is not a substrate independent entity that could, for example, just exist in the cloud. It must be an embodied agent that's engaged in dialogue in open-ended contexts that include life worlds. In terms of the methods of enhancing the reasoning, they involve socializing the agent in lived contexts through parenting, teaching, play, and other forms of dialogue. Okay. Note something here now, it's very important. The difference between a Turing machine and a Turing child is not a matter of consciousness. And it's also not a matter of getting some kind of breakthrough technology like quantum computing. That's not what we're talking about. It draws instead on a familiar basic process that we're all born capable of, and that we can learn and we can teach. And we can improve our skills at it. We can incorporate those skills into our practices as individuals and as communities and as programmers. And we can get computer systems to in turn nudge us to use them more and use them better and incorporate them in the reasoning processes of the machines themselves. So now we're on to part 4, which is where we start to have the sort of payoff. Up here, maybe not down here, but it's getting there, okay? Strategies for developing these sort of Turing child approaches in programming and collaborative solving of problems that can move us towards a wiser Earth. I'll start with a few examples and then give you the 7 strategies I want to talk about. So a key part of the shift involves thinking explicitly about how groups of people can incorporate dialogical methods in the decision processes of the groups that they're in and that the groups go through when they're using computers. And this can start in extremely simple ways. For instance, I've written a program in Scratch, which is an MIT block coding program for kids. And the program is designed to teach kids a little bit about block coding and ethics by playing with a character called Ethel, the ethical consultant robot. She's down there at the bottom center of the screen, okay? And Ethel's going to help the kids make a decision in a trolley car kind of dilemma, where they have to rescue one of 2 people, in this case, Andy, the community organizer, and the prince, who's an ecological restoration kind of person. And so they can rescue one or the other by going to them with a bus, but only one. That's the way it's initially presented, okay? But then near the end of the first round of the game, after they've been doing this kind of monological styles of reasoning, the kids that are playing are asked to list some ways in which they might be uncomfortable with their choice. They didn't like having to pick just one or the other to rescue. Or they may be uncomfortable with the way the dilemma is presented. And Ethel then invites them to list in ways which, some of the ways in which they might multiply their options. Or they might focus on interests that would be relevant to think about for the people involved. And then perhaps even change the criteria and the calculations that are allowed in the game. And then Ethel invites them to go into her programming and rewrite it to include those options and change the game. In effect, she gives them a prompt to help her reason in new ways in the future. This is just a block coding with kids, right? But it's starting, it's very rudimentary, but in a rudimentary way, to start to introduce these kinds of dialogical principles. That's the idea. Variations on this same general strategy can be done in working with adults in any context in which AI is being deployed in a community. For example, an organization that's developing software for reporting sexual assault can directly involve survivors in the ongoing redesign of the system by using dialogical methods and incorporating elements of those into the group processes and the structures of the people working with folks, and also the programs that they're using to work with them. Likewise, an organization like Consul can develop software for municipal governments using open source sites like GitHub that allow for version control. And it can adapt them to create ease of entry and interaction for community members who are not programmers, but who may want to post an issue to be worked on or take part in the discussion about why it is or isn't working as a solution. In doing so, the members of the community at large can exemplify dialogical reasoning from which the AI might itself begin to learn. So, through various kinds of learning processes. Okay, so I want to propose now 7 key principles of dialogical approaches to AI human nature systems. Sort of apply this kind of approach. And the first is that in the concepts, the diagrams, the practice, projects should always be framed as an AI human nature system. Intelligence is always an activity that's guided by values and concerns whose meanings are grounded in a holistic context. We're not just talking about a machine in a box that's the AI. We're talking about the whole system. Machines can make bits, but only a community can make a meaning. Right? So we have to start framing everything we look at in those terms. So in developing software for a farm or a trucking company or a restaurant or some other part of a food system, or a database for that matter about the food system in Brazil, for instance, it's essential to conceptualize the work not just as something that an individual does as a programmer of a computer, but more broadly as something that a community does as a shared process of dialogue that includes people and maybe also other natural organisms, as well as machines. Second, the overall goal is to arrive at genuine voluntary agreements, not to simply generate output. Genuine voluntary mutual agreements between the AI, the people, and in some sense, maybe also the other natural organisms and the ecological system that's involved in the community, that's engaged in the values and the concerns at stake. To be genuine, these agreements must, at least for the people involved, be understandable. And the machines as well, I think. They need to be based on consent. They need to be offered in a non-coercive context. So we really have to think a lot about power structures when we're dealing with any of these kinds of issues and trying to approach this. And they need to be guided by emergent objective values. We need to be thinking about how we can experimentally try and discern truths about justice, for example. Third, the AI procedures need to flag for review the cases in which their data, their algorithms, their framing assumptions, or their outputs are especially questionable and need review by a human, or maybe by a group, by a representative group of humans and natural organisms from the larger community. There should be ways for the machines to flag things like, for example, the margin of error for their sensors and say, whoa, wait a minute, we're using this, right? What margin of error are you allowing for? The limiting features of the training data for facial recognition, the possible dangers in the change of context for application if something's moved from Brazil to Uruguay, for example, or from Sao Paulo to Manaus or someplace. And also high risk factors when lives are at stake, for example, or existential threats might occur. The machine should be able to also to initiate negotiations, to start dialogical processes about issues that need to be flagged. And they should also be able to advocate appropriately for values and concerns that call for some kind of systematic consideration that people don't want to forget. They have to look at, will the budget be balanced? Will this be ecologically sustainable in key ways? Fourth, the algorithms of the programs can be modified to conform to the agreements that are arrived at. They should be able to be modified that way through easily engaged meta operations that can be relatively easily accessed by other participants in the dialogical process. Through direct intervention by people, through reform of the machine's own programming, and doing so in combination with the third principle already mentioned, with flagging things with phrases like, what should I be looking at here? Or do you have any idea why I seem to keep getting these two things confused? Or I don't get it. Why is this one an X? The dialogical interactions that the AI engages in, number 5, should be framed and guided by principles of conflict resolution as illustrated by Roger Fisher et al.'s Getting to Yes, or by John Paul Lederach's Preparing for Peace, or any of the number of other studies of negotiation and conflict transformation practices from around the world. And which practices you use will depend on where you're working, right? And you always want to draw on local knowledge and local approaches where people, they may not even talk about conflict. They may talk about, oh, we're kind of tied up in knots here, or, you know. So you have to learn and start with, in an ethnographic way, the local language. And for example, the kinds of principles, though, would take some form of something like focusing on underlying interests, multiplying options, separating the people from the problem, and looking for independent objective criteria, flagging problem points, and generating a library of specific proposals as well as strategies that might be used in various contexts. Just the way, if you're working with Python, you can draw on libraries of resources. Sixth, the AI should have a structure and a committed embodiment that commits it to the interests in the well-being of the community in which it's operating. It should be interdependent with the people and the natural systems it engages with. And it should be tied irrevocably to physical machinery and power inputs that depend on the community for their maintenance. It should not exist merely as a cloud entity that is substrate independent, that can just wander off anywhere like a virus. Right? It should be like a cell that has a local context in which it's committed, or an organism. Think of corporations, which are in a sense AI in their charters, that can move without any commitment to the local community and the kinds of problems that result. Example we might come back to. But so it can emigrate or become exported as AI capital is another way to think of it, but only through genuine voluntary agreements with the community that created and maintained it up to that point. So someone couldn't take an AI into a tribal community in the Amazon, harvest lots of data, and then just run with it, for example. And then seventh, we should work to strengthen processes through which the AI human nature system can discern tacit patterns, implicit knowledge, in the meanings that provide the context of its thought and action, and learn to make them explicit in what we might call sort of spirit-led dialogue, where we talk about, so what's the spirit of that proposal? What's the intent of that sentence? Right? Where are you going with that? What are you trying to say? We need the AI to start being able to engage in that kind of discernment. And we have to do it ourselves. Tacit patterns of value as well as fact that include both physical or material patterns, but also emergent formal and metastructural patterns in a culture, for example. The humans involved should use reflection, meditation. They may use some kind of meeting for worship, for discernment. Quakers do that, for example, or other methods to practice kind of something in the broad sense of spirit-led communal discernment. They should also experiment with drawing on distinctive forms of intelligence that are offered by machines and by natural systems. There's a really interesting book called Finding the Mother Tree by Suzanne Simard that talks about forms of intelligence in trees and fungi in the Northwest Pacific forests and how they are evolving as communities. And they should also be able to, in some sense, hold in the light not only the natural systems like watersheds or forests, but also the machines and artificial intelligence systems. So I look forward to conversation about how these 7 ideas for what we might call AI as collaborative wisdom, or CW, maybe we should even start using a different acronym, I don't know, how they might be applied in practice in your own work. But for now, I just note that I'm going to send out a copy of the book this is based on, as well as this talk. And it includes in more detail the acknowledgments, which I won't take the time to go through now. And also the resources will be available on a blog site. But for now, I'd like to turn the mic over to Paulo. And thank you all very much for your patience listening to me. I look forward very much to discussion with you all.